Hello guys, today we'll talk about the Spark architecture. Before we understand the Spark architecture, let's talk about the single machine. Once we talk about the single machine, it may be your laptop, it may be your desktop, or maybe any kind of phone. In all these components, every day or every year you will see enhancement. Not only the weight, maybe significant improvement on the RAM, significant improvement on the hard disk, significant improvement on the processor, and any other component. So manufacturers have started building parallel processor within a single machine. So what does that mean? That means you need a capability to run your instruction parallel in multiple processors at a time. Once you talk about let's say talk about the processor, let's talk about arithmetic logic unit. If you are running multiple calculation in parallel into different processors, then your result will come very fast. But the downside of the single machine is that failure. Let's say, for example, you are doing some kind of very important calculation in banking, credit or debit. Suddenly, your machine goes down during the processing. Then your job will be gone. So then we have to think through: can we do more than one machine? If one get failed, another machine can be helpful for us to run our instruction. Then comes networking and the infrastructure management. Maybe these multiple machines are put in different racks. And if you go beyond disaster recovery, those machines can be in different location, different geographic location, and they are connected to each other. Talk about the high availability. So that means a group of machines will give number of benefits. Now we are now coming to Spark. We are talking about the Spark. So now our focus in data processing world. So once we talk about the data processing, if you see we have Hadoop on the data processing engine, but there are some disadvantages in Hadoop. It has map and reduce. It's very tightly coupled with the storage. Now these days, if you see storage are becoming more cheaper and cheaper, especially if you see in the cloud and provider, whether it's Amazon, they give the S3 or maybe a Microsoft, which gives you the blob. Those are very cheaper storage. And we are taking a lot of data these days because storage is becoming very cheaper. Whether you are talking about the audio data, video data, any kind of data or log data, everything we are storing in this blob and S3. Any industry, if you are working in the banking, maybe in retail, you can collect all these kind of video information about the customer. You can collect audio information. All these data you have to end of the day you have to process and get a meaningful result out of that. So now we are talking about the data processing engine. So if you see the history of the Spark, 2009, it started in AMP lab as a research project, especially on UC Berkeley. They started as a research project and eventually it got very famous on the data processing. So Spark is more like an in-memory data processing engine, supported by the different cluster managers. Either you can use the Yarn, Mesos or standalone. It depends what kind of cluster, or even Kubernetes. You can use this kind of cluster manager and install your Spark and process your data. That will be very fast. Now let's talk about a little bit detail on the architecture side. This is very high level architecture. We'll deep dive on this. If you see below, there is in green, this is the cluster manager. Cluster manager job is to make sure that which resource is available, which is not available. Those kind of information it will say resource availability. So here we have kind of master slave architecture. Once we say master slave architecture, basically we'll have one driver node and we'll have worker node. Worker nodes are nodes where actual operation is performed. Driver node is more like a leader who will make sure that work distribution is happening properly, and once work is get completed, it is getting that kind of notification information which can be used. So let's understand more deep dive how Spark architecture works, right? Let's say, for example, user code. user submits a code, then what is the next process? So there are some of the detail we may discuss in the different sessions, but I will give brief introduction about. Let's say for example here we are submitting a suppose user code, then use Spark session. So what is the functionality behind this Spark session? Let's say for example, because we have to distribute these tasks. So what we will do? So once we submit a query, right? So we'll have logical plan, very high level we are talking about here. We have physical plan. Out of physical plan, we'll have tasks, RDDs, let's say, and these are distributed into the machine. Let's say, for example, this is machine 1, machine 2, machine 3, machine 4, right? We have one file. Suppose we have abc.txt, 256 MB. In this example, we are just taking example 256 MB. And this file have, let's say, 1 million records. And there is one simple query we want to run. Let's say, for example, we want to run here, select employee name from employee table where employee salary is greater than $5,000, suppose, right? So once we talk about the logical plan, so logical plan, what it will do, it will make sure that we have this kind of information, and this is the condition we have to apply. So what it will do, it will apply predicate push down. It will say, okay, this is my filter. So basically I have to load only this data which has salaries, employee salary is greater than 5,000, and then it will submit that for physical plan. Physical plan, what they will do, they will take a different statics, how many records are there, how many fields have the null values, how many distinct records are there, all these statics physical plan will collect. We'll put a separate presentation and the video to detail out these things, because this is more focused on the cluster architecture, Spark architecture. So let's focus on Spark architecture. So I'm just giving the brief introduction. And these physical plan, it will do, once it will create a task. Let's say for example, in this I have abc.txt file. Out of abc text file we are creating 4 different files. Let's say abc1, abc2, abc3, abc4 file. Once we created this RDD, these will distribute it into M1. Let's say M1 gets abc.txt file, 2 gets abc2.txt file, M3 gets abc3.txt file, abc4.txt file, and let's say each file have 64 MB. So driver, what the driver will do, driver will have basic information, file name abc1.txt, where it is distributed in M1 machine, what is the size, 64 KB, what time it got created, timestamp. These kind of metadata information, we can say metadata. File name, which machine it is distributed, what is the size, when it was created, all this basic information driver process will maintain. So then it will know which machine have what kind of task, and each machine will perform their operation based on the physical plan. So then M1 will say, okay, based on the data, let's say for example we have 1 million of record. So 1 million of record, let's say for example it has 250k lines. It has 250k lines. It has 250k lines. 250k lines, yani 250,000 lines are each have. Now based on this condition, let's say it returns 100k. He will say, okay, I have employee name 100k or 100,000 employee name which have salary 5,000. It will also return I have 100k employee which has more than 5,000. It will also return 100k. It will also return 100k. So driver, what the driver will get? Okay, he will say from M1 I got 100k record which has the employee salary greater than 5,000. Machine 2 I got 100k. Machine 3 I got 100k. Machine 4 100k. Now he will say add that one, right? So the once we add perform, it can be done by the M1 suppose. So total result, it will say, okay, I have total if you calculate this 400k employee name, it will give the employee name 400k record I have. This is the employee name based on user code. It will say, guys, I have out of 1 million, out of 1 million records from abc.txt file, I got answer from the my workers that they have 400k names which have more than 5,000 salary, and it will display the name. So if you see driver process, what it is doing, it is kind of leader who is maintaining all the metadata information, which machine has which kind of data, like file, what size of file they have. So that kind of all this coordination work is doing. Once he get the result out of all the 4 machine, he asks, okay, I have to, based on the user code, it will say calculate the total. So he will say, okay, now I have 400k names. These are the names which have more than salary 5,000. I think you understand how the driver process is working, right? And what is the executor and the workers are working. So this is the basic Spark architecture. In next class, what we will do, we'll understand what is the logical plan, how the physical plan works, right? How tasks are getting generated. Detail out. And our focus was purely today on the understand the driver and the worker. I hope this is giving some clarity. Thank you for watching.